go to page 140 in your journal, and you want to copy the definitions for radical equation and extraneous solutions. When you're done with this, take a look at the steps. Step 1, Step 2, and Step 3 for solving radical equations. Read through these, and you can look at the example in your packet. So go to page 9 in your packet at 5.4 example 1. We're going to do parts A and B together. Part A is asking us to solve 2 times the square root of x plus 1 equal to 4. We want the square root of x plus 1 all by itself, so we divide both sides by 2 to get rid of that 2 on the outside. The 2's will cancel, and I'm left with the square root of x plus 1 equals 2. Now I want to go to my square root of x plus 1, and I want to get rid of the square root. So that means I have to raise both sides to the power of 2. So now I have x plus 1 equals 4, and I subtract 1 from both sides to get x equals 3. Looking at part B, I want to do the same thing, except instead of dividing by 2, I have this minus 1, so I want to add 1 to both sides. And then I'm left with the cube root of 2x minus 9 equals 3. What power will we raise both sides to here? Right, we're going to raise both sides to the 3rd power to get rid of the 3, the cube root, and we're left with 2x minus 9 equals 27. What's the next step? So we want to add 9 to both sides. And we'll get 2x equals 36. Divide both sides by 2, and you'll get x equals 18. And that's it for example 1. Go ahead to the next page, page 10, and we're going to take a look at examples 3 and 4. Looking at example 3, I see something a little bit different because I see x plus 1 on this side and then the square root of 7x plus 15 on the other side. I'm not sure what to do just yet because I see x inside the square root and x outside the square root. So I know that I want to get rid of that square root. Let's square both sides. You could rewrite the problem, but I'm not because I'm just going to start from what they give me here. When I square x plus 1, I get x squared. Remember, you have to FOIL. So do not confuse this with just x squared and 1 squared. So I have x squared plus 2x plus 1 equals 7x plus 15. Now I want to just bring all my terms to one side. So subtract 7x from both sides and subtract 15. And I'm going to get x squared minus 5x minus 14 equals 0. From here, what can I factor the left-hand side into? I need two numbers that multiply to negative 14 and add to negative 5. Good, so I'm going to get x minus 7 times x plus 2 equals 0. And now if I want to solve that, remember, just set x minus 7 equal to 0 and x plus 2 equal to 0. And you'll get x equals 7 or x equals negative 2. Now, to solve for extraneous solutions, you want to plug these numbers back into the original equation. So if I plug 7 into the equation, I get 7 plus 1 on the left-hand side, so I get 8 equals the square root of 7 times 7 is 49, plus 15 is 64. So that works. 8 equals 8. 7's going to work, so that's going to be one of our answers. You could circle it. For negative 2, if I plug that in, on the left-hand side, I get negative 1 equals, and then I can stop right there because I have a square root equaling a negative number. Whatever's inside here is not going to work out. So this answer is called extraneous. And now let's look at example 3, part B. This is actually a little bit easier because if we square both sides, then we're just left with 2x plus 8 equals 3x minus 6. Go ahead and try to solve that one on your own. So you should have subtracted 2x from both sides, or you could have done the 3x, but I like to keep it positive, and added 6 to both sides so that you get 14 is equal to. So x equals 14 is my answer. Looking at example 4, this is a little bit different because I see square root on both sides. So I'm still going to square both sides to get rid of the square root. When I square the right-hand side, I'm just left with 3 minus x, so that's a little bit easier. But when I square the left-hand side, I have to FOIL square root of x plus 2 plus 1. I have to FOIL that. And when I do that, I'm going to get x plus 2 plus 2 times the square root of x plus 2 plus 1. From here, I can then move all like terms to one side. So I'm going to subtract x from both sides, and I'm going to subtract the 2 plus 1, which is like subtracting 3. When I do that, I'm left with 2 square root x plus 2 equal to the 3 will cancel out, and I get negative 2x. Now I just want to divide both sides by 2 and solve it exactly the way I was solving it before. So I'm left with the square root of x plus 2 equal to negative x. Now once I get here, I want to square both sides. And then I get x plus 2 equals x squared. And then I want to bring everything over to one side and make this equal to 0. So I'm going to have 0 equals x squared. I want x squared to be positive, so minus x minus 2. And now I can factor this into two nice factors that will help me solve the problem. X minus 2 and x plus 1. So what are my two answers? don't forget that we have 2 and -1. We have to check and see if these are extraneous or not. So when I plug in 2 to my original equation over here, I would get the square root of 4, which is 2, plus 1 is 3, equals the square root of 3 minus 2. That's just 1. So this is actually not going to work. It's going to be an extraneous solution. So you can put that same word that we put above. Okay, and x equal to -1, when I plug that in, that is going to work. So this is my only solution.